Okay, so first I'll explain the concept of linear regression, and then I will code it in Python. So conceptually, what linear regression is you're given the data between two variables, and through linear regression, we just draw the line of best fit, which helps us predict. So I'll give you an example. Let's say you're given the data of number of hours studied, so number of hours, and the corresponding test scores. Okay, let's say the data has positive correlation, looks something like this. What we do with linear regression is we draw the line of best fit of that data. But it's not as simple as grade 9 math where we're given the data and we draw the line of best fit. The computer actually has to like do it, right? So what algorithm does the computer use? Well, the computer uses the concept of gradient descent. So what gradient descent basically is we take a guess. So we'll say the slope is 0 and the y-intercept is 1. Okay? What we do is we look at this data and this line, and we're trying to minimize the error between the line and the data. So we slowly increase the slope in our case, and maybe also increase the y-intercept, increase the slope, increase the y-intercept iteratively until we get a good line of best fit. So how do we minimize this error in gradient descent? And how is the error quantified? Excuse me. So the error is quantified through something called the mean squared error. So the mean square error is literally just the error squared, like the mean of the error squared. So the error is basically the difference between the point and the predicted line. So mean is we take the sum of the actual value minus the predicted y value given the line, and then divided by the number of points to find the average. So we know that okay, yeah, and this has to be squared. Like that's literally that's why it's called mean squared error. So we know that the line is basically y is equal to the predicted slope times x plus b, the predicted y-intercept. That means we can rewrite our mean squared error as, I'll just quickly rewrite it. By the way, this is a summation sign. Okay. So now we must minimize the mean square error, right? So how do we minimize? So you probably learned in calculus, to minimize, we find the derivative and we set it equal to 0. That will give us the minimum. The mean square error is like a parabola. So we just have to find where the slope is equal to 0. Now the mean square error has two variables. So it's the slope and the y-intercept. So when you're given two variables in multivariable calculus, we learn that we must find the partial derivative with respect to the slope and the y-intercept. Let me quickly find the partial derivative. You're probably thinking now, man, all that math has finally come to use. So I'll first find it with respect to m. We first use chain rule. We bring the 2 here to negative. Okay, so this is basically the whole concept. We're minimizing the error iteratively for the slope as well as the y-intercept, and that ends up giving us the perfect line of best fit. So now let's code it in Python. Okay, so one more thing I forgot to say is that we have, in calculus, we would set the partial derivative equal to 0 for this, as well as this to help us find our ideal slope and y-intercept. But in Python, we cannot do this. Instead, we have to do things iteratively. So what we do in Python is we take our predicted slope and we decrement that slope. So we subtract the slope by, okay, let's call this partial derivative dm and this partial derivative db. So you decrement the slope by dm times the learning rate. And we do the same thing for the y-intercept. So another word for derivative is gradient, right? And gradient descent is just like decrementing by the gradient. And what the learning rate is it's a small positive number that controls how big of a step the gradient takes in the decrement. So if the learning rate is too small, the algorithm learns too slowly, and if the learning rate is too large, then the algorithm bounces the slope up and down. So we usually keep the learning rate like 0.01. It's pretty safe. Okay, so now we're gonna code this in Python. I'm literally just using one import matplotlib, nothing to do with our linear, oh my days, what did I draw? Nothing to do with our linear regression. It's only to plot our data to like see how our line of best fit is made. So let's quickly plot this on a scatter plot. plt.scatter x, y, then plt.show our data plotted. Now let's make a random line and then let's train this line. So line is equal to, I'm just going to use this comprehension to create the points on the line. Like I said, let's do slope of 0 and a y-intercept of 1. We know that mx plus b is the slope formula. So m times xi plus b for xi in x. Oh, sorry. Let me just, I'll plot this line. This is our data, and this is our line. Let's train this line now using linear regression. Let's make a function linear reg, and it'll take the points, the x and y, the points from the x and y variable. Then it will take the slope that we guess, the y-intercept that we guess, and then the learning rate, which we talked about. So we know. So for the mean, we need to divide by the number of points. So, and even for the summation, we need to go through the number of points. So let's start with finding and having the number of points, which is just the length of x or length of y. That's the number of points there are. Now we have to work with our DM and DD that we were talking about. So just refer to the start of the video where I talk about this, DM and DB. And yeah, this is just basically our formula. I'm literally just copying it from our, like the paint document that we just did. And yeah, it's just -2 times x at I times the y at I minus our predicted line. This is our DM and DB, and then the plus equals to just like we're summing it up because the DM has a summation sign, DB has the summation sign in it. So wait, for summing up, we need a for loop, right? So yeah, that's what we have here. And then, okay, first let me define DM and DB. The DM equals 0 initially, DB is equal to 0. And then once we sum up, we fill DM and DB. Okay, now we finally apply the gradient descent. We decrement the slope by DM times the learning rate, as well as the y-intercept. DB times the learning rate. And okay, and yeah, we can return our M and B. Okay, so what we have done so far is we've trained the model by going through the data once. In machine learning, you want to train the model by going through the data multiple times. And now this is the concept of epoch. Epoch is just the number of passes through the data set, through the training data. So we keep the epoch at like 1,000 or something. And basically what it means is we're just running through our algorithm epoch number of times. So we don't really do anything. We just set the number of times we iterate and just indent. Yeah. So now let us call our function and check if our line is right. So let's do b, actually let's call this m final and y-intercept final is equal to linear regression. So we'll use our points x and y. Y. We'll use our slope and y-intercept that we predicted earlier that was way off. Our learning rate will say it's 0.01, and our epoch will put as 1,000. Okay, now let's plot this line. So let's call this line final is equal to and the slope times x plus b or similar to how I got the little points for this line here. And yeah, I'll just plot it now. ELT dot plot line fine. And wow, we have our line of best fit. So also I kind of rushed through the Python code. So literally if you have any questions, I will answer it.